Okay, so this is perhaps one of the most common projectile motion problems that high school students have asked me. And it's not the best question. There's a great way to solve it, but I think that they want you to solve it a different way. So I'm actually going to solve this two ways. So the first way, so here's the problem. So the problem is you launch a ball at some angle of 35, I'm picking an angle, 35 degrees. And it travels 22 meters horizontally. And those angles could be, they give you an angle and a distance. And the question is, how high does it go? What's the highest it gets? Okay, so I suspect that they want, this is a good problem, but I don't think that that's really how far they want you to go. So they really want you to use the range equation, which is a terrible thing, okay, but I'm going to do it anyway. I'm going to use the range equation. So the range equation says that if you launch a projectile, then it goes this far. It goes v0 squared times sine of 2 theta over g. That's the range equation. Terrible, terrible. So because the problem with the range equation is it says just use that and plug in the numbers without really understanding things. Projectile motion can be more fundamental than that, but I think that's the way they want you to do this problem. So I'm going to show you how to use this range equation, and then in a follow-up video, I'm going to derive that for you and show you why it's not such a great thing to use all the time. Does that sound good? So that way we both win. You get to see how to do the problem, and I get to show what the best physics is, because that's what I like to do, physics. Okay, so if you want to use the range equation to solve this problem, here's how you do it. Well, I know the angle theta is 35 degrees. Make sure your calculator is in degrees mode or radians mode, and convert to radians if you want. Make sure you're careful with that. I know the range x is 22 meters, so now I want to, and I know g is 9.8 newtons per kilogram, which is 9.8 meters per second squared, same thing. And I want to solve for the initial velocity. So if I multiply both sides by g, I get v0 squared sine of 2 theta equals gx. Now I'm going to divide both sides by sine of 2 theta. Remember, the whole point of an equation is that you do the same thing to both sides to keep it equals. So now these cancel and I get that. Then I take the square root of both sides and I get b0 equals the square root of gx over sine of 2 theta. Okay, so now you need to put this in your calculator. Now this is something that you definitely need to do. I've seen people do this incorrectly in the calculator. You have order of operation issues. If you don't know how you're doing this with your calculator, that's something that you need to practice. So I already did this. So I mean, it would be the square root of 9.8 times 22 divided by sine of 2 times 35. Put that in your calculator, and if I put that in my calculator, I get 15.147 meters per second. Okay, so that's the launch velocity. Check that. If you're not getting that number, then just make sure you're doing your calculator right. You know, you can put it in more than one time. Do just this, g times x, and replace that with the number. Then do 2 theta, replace this with the number. Do it multiple steps. Don't do it in one step if you're not sure. Okay. Okay, so now I know the launch velocity. So this is so if I shoot it at an angle, then I have a vertical velocity and a horizontal velocity. The key to projectile motion is that I can treat horizontal and vertical motions separately. Okay, so I can just deal with the vertical velocity if I can find the vertical velocity. So here I have a right triangle, and that's the opposite side of a right triangle. So if I say sine of theta, not 2 theta, that's a theta, it's going to be opposite over hypotenuse. So that's v0y over v0. So I know v0, 15.147. So I can multiply both sides by v0, and I get v0y. So v0y is going to be 15.147 times the sine of 35. And put that in your calculator. I get 0.688 meters per second. Okay, so now we're going to do one more cheat. So now how high does it go? I just have it's going up with that initial velocity. At the highest point, the velocity is 0, so I can use the kinematic equation, which again is partially cheating, but that's fine. That says the final velocity squared, Vy squared, is the initial velocity squared, V0y squared, minus 2g delta y, which is h. That's one of the kinematic equations, and this one doesn't have time. That's why you want to use this one. So now I'm going to solve for h. Well, actually, this is 0, right? Because the velocity, the y velocity at the highest point is 0. The total velocity is not 0. It's still moving that way. So if I add 2gh to both sides, then I get 2gh equals v0 squared. Now I can divide both sides by 2g, and I get h equals v0 squared over 2g. So if I put my numbers in there, I get 3.85 meters. So v0 squared, I put in that number, 2, put in the number 2, and g put in 9.8. And that's your height. So that, and let's just think, that does seem sort of reasonable. It's going 22 meters. I'm shooting at kind of a low angle, so it's not going to go super high or super low. That just seems about right. There's other ways we can check that answer. But the most important thing is, where the heck, I erased it, does that range equation come from? And that is going to be another video that you should definitely watch, because it's awesome. You understand where that equation comes from, and you understand when you can't use it. That's the important thing.